Good morning, everyone. Welcome back. Today we're going to do 9.3.2 in algebra, building off 9.3.1, which we are graphing inequalities with two variables, but today it gets a little bit more complicated. We're going to look at linear and nonlinear inequalities. So that's our goal for today. We're going to graph like our lines and parabolas and exponential functions as usual, but we're going to decide how to create an inequality graph. So when we're graphing them, inequality graphs, you got to decide which direction you're going to shade, which side of the line or the curve you're going to shade. And so that's going to be our goal for today. Okay, so EQ for today is, what if the inequality is not linear? Well, it's actually not that complicated, as you will see in a bit. So let's just jump right into it. It says, in lesson 9.3.1, you discovered that the solutions of a linear inequality with two variables can be represented by a shaded region on one side of the line. But how can the graph of an inequality help solve a problem? And what happens when the inequality is not linear? Consider these questions as you complete the following problems with your study team. 9-77 says, you review what you learned in the graphing inequalities in lesson 9.3.1 by graphing this. Okay, and to graph this, you would just graph it like a normal line, right? So this is what we did in the last lesson. Go ahead and pause the video right now and see if you guys can graph this, and don't forget to determine what type of line is it going to be. Is it going to be a solid line or a dotted line? And then which side of the line are you going to shade? All right, so go ahead and pause it right now. Okay, welcome back. And your graph should have looked like something like this. This is the equation or the graph of y equals -5/3 x minus 3, but because the inequality is not an equal sign out, it's greater than or equal to. Remember, greater than or equal to means it's going to be a solid line because of that or equal to. And then because it's greater, we're going to shade up, meaning above that line. Make sure you're not going left and right. You're going either above the line or below the line, okay? And so question A says, well, what is the minimum number of points you need to test in order to know which side of the line of the solution falls on? You actually need to only test with 1 point. We haven't talked about testing points yet, but we're going to jump right into that here with problem B. Orville thinks that using the point 0, 0 to test this inequality is a great idea. Why is this point so convenient? So when we are testing, we're going to go to the actual inequality itself. And Orville said we're going to use the ordered pair 0, 0, meaning 0 is x, 0 is y. That means we're going to substitute 0 for x and y. And we're going to see if this statement is true or not. So let's just quickly simplify this. 0 is greater than or equal to, well, this whole mess turns into 0. So we get -3. So you're going to ask yourself again, is this true or false? Right? Is 0 greater than or equal to -3? And yes, 0 is greater than -3, right? And let's go over here to the graph now. I tested with this green dot right here, this green point, the origin, 0, 0, right? Because this is true, that means that point is on the side of that line that should be a solution. And that side is, as you can see, it's on the top side of this line. So that's what's essentially me saying, because I've tested it, I chose a point that's above this line, and that point is true. Therefore, that must be the true side. That side is the solution side. So that's why we shade that side. Now, if that point were not to be true, that would not be a good answer, and then I'd go ahead and shade the other side. Okay? And again, you get used to this. It's pretty self-explanatory once you do a few of these. Okay, so it says, why is using this point so convenient? Well, why do you think it's so convenient? Think about how quickly we solved that. It was pretty quick, right? We plugged in 0 for x, 0 for y, and it was super easy and fast to solve. Then it says, for problem C, Anita decided to use the point -3, 2 to test the inequality. So let's go ahead and test that. -3, 2. Okay. Oops. Let me change this here. let's see what happens if we substitute 2 for x, or excuse me, negative 3 for x and 2 for y. Okay, so there's 2 greater than or equal to 5/3 negative 3 minus 3. Well, a negative 3, oh, the 3's will cancel. I still have that negative times a negative, so that's going to be a positive 5 minus 3. So 2 is greater than or equal to 2. Is this true? All right, so again, true or false? Is 2 greater than or equal to 2? Yes, it absolutely is. 2 is equal to 2. So now let's find that point on our graph. Negative 3, comma 2. Here it is. Let me change the color here. We'll use purple. It's right there. Negative 3, comma 2. Okay. Now, excellent. We found out that it was true. It's part of the solution. What's our problem now? You guys see our problem? Like, how do I know which side to shade? Should I shade above the line? Should I shade below the line? This obviously is not going to be a good point to test with because it's directly on the line. So whenever you're testing points, you don't want to test a point that's directly on your graph. You either want it on one side of the graph or the other, okay, but not on. So this one, although we did figure out that this is going to be a true statement, it just doesn't make sense because it doesn't help us determine which side to shade. Let's go ahead and move on to the next problem here. We're going to skip 9-78 because it's not a particularly effective problem for you guys to do, especially from home by yourselves. If you want, you can go back and try to do that on your own time. But we're just going to do the rest of the problems from this lesson. So from 9-79 to 9-82. Okay. 9-79 says, what if this inequality is not linear, non-linear? Decide with your team how to graph the inequality on your graph paper. So your graphing shortcuts can help. All right, go ahead and pause this. And I want you guys, when you create this, when you draw the graph, it's going to be a parabola, obviously, because this is a quadratic. When you draw your graph, again, you're going to ask yourself, is this going to be a dashed parabola? And then which side of the parabola should we shade? Okay, go ahead and take a couple minutes to see what you guys come up with. Okay guys, so welcome back. I plotted some just some quick points, or as quick as possible at least, and you didn't have to have a perfect looking graph. You notice the last sentence of this problem 79 says your graphing shortcuts can help. So if you remember a few shortcuts, what I wrote in red is when you factored and you use the zero product property to find your zeros, your x-intercepts. So I have an x-intercept of 3 and I have an x-intercept of 1. And those are those red points on my graph there. And then the green, I circled the 3 in the equation, and the green, it's the y-intercept is at a positive 3. And then the vertex formula, which is in blue, and the vertex formula allowed me to find the x value of the vertex, which is 2, but then I need to find the y value, so I plugged the 2 back into the original equation and solve for y. So my vertex is 2, negative 1, and that is that blue point. So that is more than enough information that I'm going to need to just kind of sketch a parabola. Okay, so when I'm sketching it, again, I'm at, because this is a y is less than, I'm going to use a dashed line or dashed parabola. Okay, so doesn't have to be perfect, just that's good enough. And then because this is now inequality, I have to determine which side I should shade. So parabola is a little bit more confusing because there isn't, like, it's harder to determine, like, should I shade above the parabola or should I shade below the parabola. So what you always can do to help you determine how to shade is you just pick a point. Any point that you want to pick, like I could pick this point right there, which is negative 4, 4. I could pick this point over here, which is going to be 7, 2. But what do you guys think the easiest point for me will be to use to check? Right? Well, you guessed it. It's 0, 0. So So I'm going to use that point, 0, 0, and I'm just going to, again, substitute it back into my original equation here, and then determine if this is true or false. So I have 0 is less than 0 squared minus 4 times 0 plus 3. Okay, and again, the use of zeros makes things super easy and fast. So I ask myself, is 0 less than 3? 0 is less than 3, so this is true. Because this is true, that means my point here that I tested, 0, 0, is a good point. Therefore, that is a side, that's the good side, right? So that's the true side. So I should shade everything on the outside of my parabola, if you will. Okay. Obviously, the parabola is going to go much higher and extend it all the way like that, something like that. Doesn't have to be super accurate. Oops. Like that. And then so I would shade everything right there. Okay. That's it. If you want to pause the video and screenshot this or copy this, make sure you do that right now because I'm about to erase it. All right. Let's move on to the next part here. So 9-80 says go ahead and try to graph these inequalities the best that you can. Remember, with you don't want too much detail, you just want a rough sketch. The emphasis here isn't on can you graph it accurately or perfectly. You should still be able to graph it accurately. I would not go straight to Desmos right away because it's good practice for you guys to know how to graph. Now obviously if you're stuck you can go to Desmos, but I'll explain it right after this anyway. So go ahead and pause the video, take as much time as you need, come back when you guys think you are done. Alright guys, here's your result for problem A. Remember, we only really need a test or use 2 points to create our exponential graph because that's not super important. It's not super important to have too much detail in it. So when we plugged in 0 for x, 1.15 to the 0 power is 1, so 1 times 4 is 4. When we plugged in 1, you're going to get y equals 4.6, and the inequality is less than, so it's a dashed line, not a solid line, or not a line but a curve. And then to test that point, or to test where to shade, we're going to use 0, 0. 0 for x, 0 for y. And when I solve this, 0 is less than 4, therefore it's true. That means that point right there, oops, that point is a good point. Okay, so that's the good side. The good side is where you're going to shade. All right, let's move on to the next one. Okay, so here's what I got for part B. Again, really quick graph. This equation's already in graphing form or vertex form. You're going to look at the h value, which is a positive 6, and your k value is 3/4. So remember, you take the opposite of that and you keep that. So that is your vertex right there. And then to find the y-intercept, as real quickly, your y-intercept is where x equals 0. So I substituted 0 in for x into my equation. And then I simplified everything and I got 9 3/4 for y. So 0, 9 3/4 is going to be my y-intercept. And that's all I really needed for now because, again, the point of this problem is just to determine what type of parabola is it going to be. Is it dashed or is it going to be solid? And then which side do I shade? So let's go to the blue part here where my work is in blue. I substituted 0, 0. And as you can see, 0 is not greater than or equal to 9 3/4. So this statement would be a false statement. The statement is 0 is greater than or equal to 9 3/4. That is not true. That is false. So when that's false, that means this origin that I've tested right there, that is a bad point. So if that's a bad point, you don't want to shade that side. That means that's telling you the side that is not a solution. So what are you going to shade? You're going to technically shade the inside part of the parabola. Okay? All right, let me pull up the third one here. Give me a second. Okay, so here's our third one. X is less than 2. So because this is a coordinate plane that it's giving you now, it's not a number line, you need to graph this in in regards to the x and y axes. So if x is less than 2, you just want to graph the line. X is equal to 2, which I have in red there. And then because it's just less than, not less than or equal to, it's going to be a dashed line. And so you can also test with 0, 0, or in this case, just 0. So 0 is less than 2. That is true. That means this point right here, where x is 0, you don't have a y value, so you just ignore it. That means that's the good side. So you're going to shade the good side. That's it. Okay, let's move on to the next problem. All right, 9-81. Now it gives you an inequality. Just go ahead, or it gives you the graph of an inequality. Can you give us the actual inequality itself and explain how you found the rule? Okay, go ahead and pause the video, give it a shot. All right, I'm back, and basically all I did was I found the equation in slope-intercept form. This is our y-intercept of -1. To find my my next point, I did delta y over delta x, rise over run. My slope is -1/3, and then this is a dashed line, so it's y. It's the inequality is going to be less than, because remember it's below, so left is less than is you're going to shade below your line. Okay, so you could have also tested with 0, 0. Just save some time. I knew that below, anything below that line is going to be less, so therefore it's just going to be a less than symbol. Okay, and then the last problem here for today is going to be this inequality in absolute value form. So it says to graph the inequality, y is less than the absolute value of 2x minus 1. Let's see what you guys come up with. If you're not sure, anytime you're not sure how to graph anything, guys, whether it's an inequality, or whether it's a line or a parabola, or in this case it is absolute value, just create a t-table and see what you guys come up with. The hint here is your absolute value graph, if you recall, it's going to look something like a V. Okay, so this V, that vertex point, you are going to, that's going to help if you know what that vertex point is going to be. All right, so see what you guys come up with. Go ahead and pause it. Just come back when you're done. All right, welcome back. So I do want to solve this all the way. Before I just wanted to jump in halfway, start explaining it there. I think it makes more sense to you. So I created a t-table here. That middle column here is going to be the actual algebra work. So on my left column, I have my x value of 0. When I plugged it in, the absolute value of 2 times 0 minus 1. So 2 times 0 is 0. 0 minus 1 is a -1. The absolute value of a -1 is a positive 1. So you recall, absolute value is the distance from 0. Can't ever be a negative number. Okay, so let's go ahead and plot that point here. We'll change it to purple. 0, 1. It's going to be right there. So let's just try our next value here of 1. So 2 times, absolute value of 2 times 1 minus 1. Well, 2 times 1 is 2, and 2 minus 1 is 1. The absolute value of 1 is 1. So when I plugged in a 1, I got a 1. Oops, let me change that to purple here. Okay, that's interesting. So you recall, I told you guys this is going to be a V shape right before, right? Let's just, oh no, I accidentally erased that. Dang it. Give me a second, I'll be right back. All right, I got it back. So again, I said it was going to be a V shape, and so far I have 2 points that have the same Y value. So I know it's going to, it's both going to point upwards, because that's what absolute value graphs are going to be. So my next point I want to choose for my X value is going to be a half. Right? So the reason why I'm choosing a half is I'm looking at the equation and I'm asking myself, what value of x can I plug in there for in order for me to get 0 as my y value? Okay, and also it's my halfway point between 0 and 1, which is what my two x values are here. So let's try a half. Let's see what we get. Absolute value of 2 times a half minus 1. So 2 times a half is half of 2 is 1. 1 minus 1 is 0. Absolute value of 0 is 0. So 1/2, 0. Right there. Oops, let's use purple. And there it is. Okay. This is going to be, again, this is just less than, so I want to create a dashed line. And it's just a really sloppy sketch here. And then, should we shade above the V graph or on the outside or below it? So again, we'll just choose, if you aren't comfortable by now, if you haven't figured it out by now, we're going to choose the easiest point to choose, which is 0, 0. So we're going to go y is less than the absolute value of 2 times 0 minus 1. And sorry, it's not going to be y, it's going to be 0, right? Because we're choosing 0, 0. So the absolute value of 2 times 0 is 0. 0 minus 1 is negative 1. The absolute value of negative 1 is a positive 1. So is this true? Is 0 less than 1? Yes, it absolutely is true. Because it is true, that point is the good point. And that it's on the good side. And so the side is really all of this right here. That's it. Okay. So to close our lesson today, why don't you guys just give me a one or two sentence summary of how do you know like what side you could shade? Just in 1 or 2 sentences, give me 1 or 2 ways that will help you guys determine where you would know how to shade an inequality. All right. Other than that, if you guys still have questions, please, again, shoot me an email or set up a meeting on Calendly, and I will be available probably on Wednesday for another video conference, Wednesday morning. And yeah, hope you guys are doing well. Hope you had a great weekend, and I will talk to you guys soon. Bye, guys.